Okay, 3.1 and 3.2 review. On 1 through 3, the instructions say to use the definition, and it gives us a formula to find the derivative of the given function at the indicated point. So it gives us this formula up here, which we've used before, and it gives us a function on each problem as well as a value for a. So what we're trying to do is we're trying to say the limit as h goes to 0, because that's in our formula, of f of a plus h. But since they told us what a is, we're gonna put the value for a in where a is. So this is f of 1 plus h minus f of 1, because 1 is what a is, and that's all over h. The next step is that we need to actually figure out what f of 1 plus h and f of 1 are. And so to do that, we put 1 plus h where x is, and then we put 1 where x is. So this is still the limit. If I plug in 1 plus h for x, I have 3 minus 3 times 1 plus h, minus what I get when I plug in a 1 here. And so it's easier actually if you go ahead and work that out some other place and then just put the number here. So 3 minus 3 times 1 gives us 0. We need to distribute this negative 3. So that's 3 minus 3h over h. At this point, some things should cancel, and they do. 3 minus 3 is 0. Negative 3h over h simplifies just to be negative 3. And so since there's not an h left to plug into the 0, then that means that the answer is negative 3. If this had said negative 3h, I would plug in 0 for h and get a different answer. But it doesn't. It doesn't have anything that I can plug in. So my answer is just negative 3. So 2 and 3 ask us to do the same thing. We're just going to use that formula. The simplification on each of these is slightly different because our functions are different. So a is 1 again, so this first step looks the exact same as what it did on the previous problem. But since my function is different, it's 6x squared, when I plug these in, they'll look different. So the limit as h goes to 0. If I plug 1 plus h in where x is, then that's 6 times 1 plus h squared. All I did was I wrote 6x squared, but where x is, I plugged in 1 plus h. That's what f of 1 plus h means. Minus, if I plug in 1, what do I get? 6 times 1 squared is 6. That's all over h. Now to work this next part out, we need to FOIL 1 plus h times 1 plus h. We also will have to distribute the 6. So if I just start off FOILing, that's 1 plus 2h plus h squared. Then I distribute the 6. And you need to do it in that order. Well, you don't have to, actually, I guess. You could distribute the 6 into one of the parentheses and then FOIL, but you wouldn't put the 6 in both parentheses and then FOIL. That would be bad. So this is, when I distribute the 6 plus 12h plus 6h squared minus 6 over h. Now things are going to cancel. 6 and negative 6. And then the top has an h in common that I can take out. I can say that, sorry, I didn't like that h. I can take the h out, and I'm left with 12 plus 6h. If I do that just to these two terms that are left on top. And what that does is it lets me cancel out the h on top and the h on bottom, so that I have the limit as h goes to 0 of 12 plus 6h. Since there's not an h on the bottom of my fraction anymore, I can plug in h. H is 0, So 6 times 0 is 0, which means this is just 12. On number 3, we're doing the same formula, just a different type of problem. This time a is -5. So I've set up my formula. Now I just need to plug -5 plus h in for x. So that means that on the bottom of my fraction, where x is, I need to put -5 plus h minus what I get if I plug in a -5. So if I put -5 on bottom, that gives me +4/5. And so I'm plugging a +4/5 in here, so it's -4/5. You do need to be careful about those signs. Anytime we have fractions like this, our goal is to find a common denominator. The first denominator needs the second. The first fraction needs the second denominator. The second fraction needs the first denominator. -4 times 5 is -20. I want to distribute this -4 into this parentheses. So that's my plus 20 and then -4h. My common denominator is these two denominators, 5 and -5 plus h. And that's all over h. I forgot to write my limit over here. Now things should cancel. -20 plus 20, giving me the limit as h goes to 0. -4h is still on top. It didn't get canceled. 5 times -5 plus h is on bottom. What I'm going to do is I'm going to take the h on the bottom and multiply by the reciprocal, because that's how we divide fractions. So this h on top and this h on bottom cancel. I can't cancel the h on top with the h that's right here because this is being protected by this plus sign in between -5 and h. So this becomes -4 over 5 times -5 plus h. So now I can plug in 0 for h. And then work this out. This is -4 over -25, which is +4 over 25. Now we're going to switch to the other definition, the definition that is actually easier to use most of the time, but it just kind of depends on our factoring skills in reality. So I have a value for a that is 10. And so I'm going to plug that into my formula everywhere I see a. So the limit as x goes to 10 of f of x minus f of 10 over x minus 10. So now what I need to do is plug these things in. F of x is simply my function they gave me, which was -2x squared plus 10x. F of 10 is what I get when I plug in 10, so I might need to pull out my calculator to do that, or I might not. This is -200 plus 100, which is -100. And then, like I said, the hard part of this is the factoring, although really this isn't terrible factoring. It could be worse. They all have a 2 that I can take out on top, so that's the first thing I'm going to do. And it'll actually make it easier in the long run if I take a -2 out, so that this will become a positive x squared. So I get negative 2 times x squared minus 5x plus 50 over x minus 10. My next step for factoring is going to be to factor this into two parentheses. So I need to say what multiplies to get 50 and adds to get negative 5. Notice I have to keep writing out this negative 2. It doesn't just go away. So I need to have x minus 10 and x plus 5 over x minus 10. This is how you know you're using this formula right, is now something should cancel the bottom, which it did. And then what's left over, we should be able to plug 10 into. So negative 2 times x plus 5. I'm going to put 10 in where x is. So that's negative 30. Now let's do one where we've got a fraction. So the same formula, that we used, except now a is 6, or negative 6 I mean. Kind of a big deal. And since it's negative 6, on bottom here I'm going to have x minus a negative 6. So that's really x plus 6. So if I fill these in, then that means I'm going to put f of x, which is negative 8 over x. Then I'm going to subtract what I get when I plug in negative 6. So if I plug in negative 6, I get positive 4/3. You technically don't have to reduce that. I would at least get rid of the negatives. They cancel each other out. That'll make things easier for you. But technically, if you leave it as 8/6 through this whole problem, then you should still be able to come up with the right answer in the long run. It's better to simplify fractions. It makes things easier, but you know, whatever. So that's 4/3 over x plus 6. Now we want common denominators. So the first fraction needs a 3 and the second fraction needs an x. So that means I have negative 24 minus 4x over my common denominator, which is x and 3, so 3x, over x plus 6. Now I can factor on top right here. I can take a negative 4 out of both of these and then flip them around if I want to. If I take a negative 4 out, that leaves me with x plus 6. And so what's going to happen is, because we're dividing by x plus 6, we can think of it like this. I'm doing times 1 over x plus 6. Because this is just like with our h on the bottom. This is over 1, and we're flipping it so that we can multiply. So the x plus 6's cancel, leaving me with negative 4 over 3x. Which, when I plug in negative 6, gives me negative 4 on top and negative 18 on bottom. And then the negatives cancel, and I can also cancel a 2, so this should be 2/9. The final one in this section has a square root. A is 11. So I'm going to do the limit as x goes to 11 of f of x minus f of 11 over x minus 11. So when I fill that in, I fill in f of x, so that's square root of x plus 5, minus what I get when I plug in 11. 11 plus 5, under our square root, we get 16, we square root it, and we get 4. So this is minus 4. Now here's the part you have to memorize as far as steps go, is to fix this, because right now I can't plug in 11. I need to rationalize the numerator. So I'm going to multiply by square root of x plus 5 plus 4. The only thing I change is the sign that's in between the square root and the number. So on top I need to FOIL, although because of what I picked, I don't actually FOIL so much as I do first and last. First, x plus 5 times x plus 5, both under the square root, gets rid of the square root and gives us x plus 5. My outer term would be a positive 4 square roots of x plus 5. My inner term is a negative 4 square roots of x plus 5, so they cancel. And last is negative 4 times positive 4, which is negative 16. My 5 started looking like 6s, so sorry about that. They were not. On top, 5 minus 16 gives us x minus 11, and so that's good. That means that these cancel, and so that gets rid of our issue on the bottom. So make sure though, since I canceled everything out on the top, that's 1 over the square root of x plus 5 plus 4. Then I plug in 11. So that's the square root of 16 again, which is 4 on bottom, but I'm doing 4 plus 4, so that's 8 on the bottom. So my slope, or my derivative, is 1/8. Okay, on number 7, this problem is different because, for one thing, the way they ask it, anytime you see this fraction that has d's in it, d is for a derivative, if you want to remember it that way. So we're finding the derivative of this function, and they didn't ask us at a certain point. So all these other problems have said a equals something, and we don't know what a equals. And so when we use our formulas, which I'm going to use the second formula because most of the time it's easier, where I have an a here, I have to keep it as an a because I don't have any number to put there. So this is the formula I'm going to use, and it's not actually any different than what's on the front of your review because there's no number to put in for a. We just need to fill in f of x, which is simply our function. This is f of x. So I'm going to put the limit as x goes to a of 4 minus 15x minus f of a. Well, that means where x is, I need to put in a. And so I need to put parentheses around this because I'm subtracting this whole thing, and it's 4 minus 15a. So f of x is 4 minus 15x. F of a is 4 minus 15a. It's all over x minus a. And I'm subtracting them, which means I have to distribute this negative into the second set of parentheses. So that means I have 4 minus 4, which will cancel each other out. And I have negative 15x plus 15a. Just like before when we were doing these problems and we had a number for a, at this point our goal is going to be to factor so that something will cancel the bottom out. So you may notice on top they both have 15, so we're going to take that 15 out, but also we're going to take a negative out, because if we don't, then our signs won't match up with the bottom and we won't be able to cancel. If we do take out a negative 15, we get positive x minus a, and that's what we want. I forgot to write my limit. So since they're both x minus a's, we can cancel them out. And all we have left now for our limit is negative 15. Everything else except that number canceled. Well, if I don't have an x to plug into, then my answer is just whatever my limit is. So x is going to a, but there's no x, so my answer is negative 15. On 8, we want to find an equation of the tangent line to the graph of y at x equals 3. We need two things for the equation of a line. We need slope and we need a point. And so what they've told us is the x value of our point. We can plug that in and find the y value, because remember, we'll need that anyway in a little bit. So if I do that, that's 27 minus 27 minus 3, so that's negative 3. So what we're missing is the slope, and to find the slope, we take the derivative of the function they gave us using one of our two formulas. So try the second formula, and if you can't get through it, then switch to the other one. Especially on this problem, the second formula is way easier. So x is going to 3, because this is our a value, and then we want to do f of x minus f of 3 over x minus 3. So let's fill in f of x and f of 3 on top. F of x is just our function, x cubed minus 9x minus 3. F of 3, that's what we did when we found this right here. When I plug 3 in, I get negative 3. So since I'm subtracting a negative 3, that ends up changing to a plus 3. It's all over x minus 3. Now, the negative 3 and the positive 3 cancel each other out. So on top I have x cubed minus 9x, and on bottom I have x minus 3. My goal is to try to cancel out the x minus 3, but as always, I need to factor to be able to do that. So the first thing I want to do when I factor x cubed minus 9x, which is all that's left on top, is I'm going to say those have an x in common. So let me take out that x. So that gets us a little bit closer, but we still don't have anything we can cancel out. So my next step is going to be to try to factor x squared minus 9. That's the difference of two squares. And so what that's referring to is x is squared, and this is the same as 3 squared. And so I can split this up into x plus 3 and x minus 3. You take the square root of this number 9, and that's the number that goes in here. We need one that's positive, one that's negative. The other way to think about that is we're trying to figure out what multiplies to get negative 9 that adds to get 0, because normally we have a middle term here, and we don't. So it'd be like it's a 0x that we're trying to get to. 0x, not ox. The x minus 3's cancel. Yay! What we wanted to have happen. So the limit as x goes to 3 of x times x plus 3. Well, we can plug in 3 now because we got rid of our problem on the bottom. That's 3 times 3 plus 3. 3 plus 3 is 6. 3 times 6 is 18. That's our slope. It wants the equation of the tangent line. So that's y minus our y value. So that's y plus 3 equals our slope times x minus 3. Number 9 is really similar in that it wants us to find the equation of a line, but this time it's the normal line. So remember that normal means perpendicular. So to find it, that's where we have to do the opposite reciprocal of the slope we get. They even told us the whole point, which is nice. I'm going to use the second formula. And this is my a value, negative 2. I'm going to do f of x minus f of a over x minus a. And since a is negative, that means this is going to be x plus 2. So the limit as x goes to negative 2 of my function, f of x, so 5x plus 5x squared, minus what I get when I plug in negative 2 to this. So either I need to plug in negative 2 and find my answer, or maybe we realize already that f of negative 2 is the other part of this point, which is 10. So this should be minus 10 over x plus 2. Now, we need to try to factor the top. Always look for like them having something in common all the way across, because it makes factoring way easier if we start off by taking out, in this case, the 5 that they all have in common. I'm going to take out the 5, and I'm also going to switch it so the x squared is first, because that's how we're used to factoring. Make sure you take 5 out of all of them so that this is a -2 at the end. It's an easy thing to accidentally not do. So now I need to say what multiplies to get -2 that adds to get 1, which will give me +2 and -1, which is great because then the x plus 2's cancel, leaving me with 5 times x minus 1. That's what I need to plug -2 into. So this is 5 times -2 minus 1, which is 5 times -3, which is -15. Now that's the slope of our tangent line, but we want the slope of the normal line. So I'm going to take this, flip it, and change the sign. So the slope I want to use is positive 1/15. And the point I want to use is the point they gave me up here. So this is y minus 10 equals 1/15 x plus 2. Okay, for the next few problems, I just want to remind you about this whole thing called differentiable, we'll go with. A function is differentiable where you can find the slope of it. And so for most of our normal graphs, things are pretty differentiable. By a normal graph, I mean like a polynomial, so like lines and parabolas and things like that. Those are all differentiable because they're really simple, easy graphs that anywhere along this parabola, I could think about a point and I could think about the line tangent at that point and what slope it has. There's 4 times that we absolutely can't take the derivative of something. So that means it's not differentiable. And that happens in these 4 cases that I have visualized here. So the first one is a corner. This is an absolute value graph. Here at this spot in the middle, the problem is that the slope of this would not be like a horizontal line, because on the left side of this, as we get close to 0, we're at like a -1 for a slope. If we come from this other side, we're at like a +1. And then like when they meet in the middle, like there's nothing that tells us what slope that should be then. So a corner is bad for being, as far as being differentiable. A cusp, which is really just like an extreme corner, is also bad. And so this is kind of a complicated graph to get. You have to have, or one of the easiest ways to get this graph is to have a cube root, but also an absolute value involved. And so what that does is it creates this really extreme looking, it's not a corner, it doesn't have like a, like this is like a right angle almost. It's more extreme than that. It's curvy, actually, is the real difference. This is curvy, these are straight lines. A vertical tangent, this is a cubic graph, like a regular one, and so it is talking about at 0 here. If I try to draw a line that is tangent, I get this vertical line, and the slope of a vertical line is undefined. And so that means I can't find the slope because it doesn't have one there. So that's an issue. All of these issues, by the way, are only at 0. Anywhere else on these graphs, we could find the slope. The fourth way is if it's discontinuous here at 0, which it is because there's a vertical asymptote. This is the graph of 1/x. If it's discontinuous at 0, you can't find the slope there because nothing is happening there. So now let's do those problems. The whole rest of the review is related to this. So determine the values for x for which the function is differentiable. So what we want to do is either think about the graph or actually graph it. It's safer to actually graph it. And so I have in orange here the graph of negative 7x plus 5. What I'm doing is I'm looking for corners, cusps, vertical tangents, or discontinuities. None of those things are happening, which means this is differentiable the whole time. So from negative infinity to positive infinity. Moving on to the next one, on 11, I would graph that, and I see that there is a discontinuity right here. It's a vertical asymptote, and remember, we know how to find vertical asymptotes just by looking at our function. We set the bottom equal to 0 and we solve and say, okay, that's at negative 6. We can also, if we have it graphed, we can also look at the table of values. But what this means is at negative 6, there's a discontinuity. And so we can differentiate everywhere except for negative 6. And so that's what our interval notation is going to look like. It's going to go from negative infinity to negative 6, and then from negative 6 to infinity. Our final question, number 12, not final for this section, is a square root function. And so what matters on the square root function is I can find the slope over here just fine. I can, pick a point and draw a line tangent to it. But over here in my negative numbers, even up to like 1 and 2, nothing is happening. And so I can't find the derivative any of these places where my graph does not exist. So this is differentiable starting at its point right here, which if we look back at our function and set it equal to 0, we know that that point that it's starting at is 3. And so from 3 to positive infinity, this function is differentiable. Now, we're not differentiable at our endpoint, so I would put a parentheses here instead of a bracket. This is different than domain. If I wanted the domain of this, I can plug in 3 and get an answer, and so that'd have a bracket. I'm talking about, can I find the slope at 3? And I can't, because 3 is an endpoint. It doesn't go anywhere past 3. The next section asks us to actually tell which of these is happening, a corner, cusp, vertical tangent, or a discontinuity. So it's kind of a matching situation. So I have these, I think, graphed here because I was like totes prepared for this. So negative 6 absolute value of x minus 1 is a corner because we have a sharp, not a sharp, because we have 2 straight lines that are meeting, and that's a corner. Our next one, 7 over x plus 7, is this blue graph. And it actually asks us specifically at x equals negative 7, what's happening? Well, that's an asymptote, which is a discontinuity. And so that's what we would put. 15 and 16, these are some weird looking graphs that actually might be difficult for you to type in at first. The cube root button is under math. It's like the 4th or 5th option. I don't remember for sure, but you can find it under the math menu. Then the absolute value bars, which I guess I should have mentioned earlier, is math. Scroll 1 to the right and it says ABS, and then if your calculator's old, it'll type ABS in and have parentheses. If it's newer, then it'll give you the absolute value bars. So 15, if I graph it, I have this cube root graph, which here in the middle at 0 has a vertical tangent. And so that's what we would put, is vertical tangent. So that leaves us with the cube root of the absolute value of x plus 5, which these last two I definitely wouldn't expect you to know right off the top of your head what they look like. But this is a cusp. The ones that are cusp look kind of like an open book or a bird, if you are into drawing things like, like birds flying, or like an open book, like, because that's fun. So that's what cusps look like, and this is a cusp. Almost the last section. This asks us if the function at a certain x value appears to be differentiable, continuous but not differentiable, neither continuous nor differentiable. So if something is differentiable, it will be continuous at that point. That's like a has to be kind of thing. So what we're looking for is this continuous, which it is. And so since it's continuous, can I find the slope at x equals 0, which is what it asked me up here. And so I can. This is a line. There's not any of those 4 things that cause me to not be able to differentiate. So this is differentiable. Here, we look at x equals 0 and we say, is this continuous? Because if it's not continuous, then we know that it's neither continuous nor differentiable. So since it's not continuous, we can't find the slope at x equals 0. It has a point there, but a point isn't good enough. So this is neither continuous, nor differentiable. The next one has actually the same issue. It's asking at x equals 1. At x equals 1, this is not continuous. If it's not continuous, it's not differentiable. So this is neither. So we didn't have that other case, the case where it was continuous but not differentiable. So this last problem actually is an example of that. This would be a continuous function because I can draw it without picking up my pencil. But there are 2 places where it's not differentiable. Those 2 places are where we have these corners. There's one up here, there's one down here. I just need to tell the x values where that's happening at. X equals -2 and x equals +2.